Welcome to Ezel Engineering YouTube channel. In this video, I will show you how to model, analysis, design and get a detailed structural drawing for math or Raft foundation shown on the screen one by one into two parts. Watch this video up to the end since the last point is a game changer. Subscribe my channel and share this video to structural engineers, site supervisors, contractors, civil engineering instructors, and students, clients who need structural plan. Let's dive into the video. First of all, I would like to tell you design parameters from ETABS output and geotechnical data or that of soil data. The final outputs of our math foundation looks like this. We have to going to design this foundation in detail. First of all, we have to use a math foundation when the column axial load is high, from the column load from the superstructure is high, bearing capacity of soil is low if there is a weak bearing capacity of soil, and if there is a differential settlement. So the final outputs from the ETABS software looks like this. The corner column have a dead load of 200 kilonewton and a live load of 150 kilonewton, and the side face column, that is the column on the side face, have a dead load of this and a live load of this, and that of the center column. The column at the centers of our project have a dead load of 300 kilonewton and a live load of 170 kilonewton. The parking live load is 5 kilonewton per meter square. And from the geotechnical data or from soil data, the bearing capacity of soil is 200 kilonewton per meter square. And the permissible settlement for math foundation is 15 millimeter. And the factor of safety is given as 3. From this geotechnical data, we can calculate the soil subgrade modulus, which is very important data that we have to enter into this safe software. I will show it later. So your subgrade modulus is calculated as bearing capacity of soil times factor of safety divided by the level permissible settlement. So you can get as this as like this. So let's proceed to safe version 2.1 software, and I will show all the design one by one. Let's start our design. Okay, first you have to open your safe version 2.1 software. From this, it's better to click on new model. After that, our model initialization box is coming like this. From this, you have to enter all the necessary data based on your building code of standard. Here in Ethiopia, we have to use European norm of standard, because Ethiopian building code of standard is similar with that of European norm of standard. You can use other countries' design or building design codes. If you are in India or in America, you can use any building design code. So here in Ethiopia, we have to use that of European norm of standard. So our display unit may be in a metric SI unit. So you have to select this. And the region is for default material. I have to use any code from this, but in our case, it's better to use European norm. And steel section database. At this time, it's not actually necessary, because I have to use concrete and have to use a reinforced concrete structure. So steel database is not necessary, but it's better to use Eurocode. A steel design code for your reinforcement area. It's better to use Eurocode for 2004. And for that of concrete design code, it's better to use also Eurocode to 2004. After filling this data, you have to make it okay. After this, our grid spacing is coming like this. From your given data, you have to use 1, 2, 3, 4, 5 columns along y-axis with spacing of 5 meters apart each other, and in x direction 1, 2, 3, 4, 5 with 4 meter spacing between them. So you have to go to your safe software. After that, number of grid lines in x direction. Number of grid line in x direction is 5, and number of grid lines in y direction is also 5. And spacing of grid in x direction, as I told you, we have to use 4 meter spacing in x direction and 5 meter spacing to the y direction. After that, I have to put your grid labels. So for X grid ID, you have to use letters, and for Y grid ID, it's better to use numeric data. So you have to make it okay. After that, all the spacing is good, so it's better to select grid only. You can use all these design templates for your flat slab design or any design. For example, you can use this for a base mat or combined footing, or release single or isolated footing. You can use this template, but in our case, it's better to use grid only and edit our data further. So have to click on grid only and make it okay. After that, the grid data that you have to enter is coming like this. After this, it's better to go to define your material. To define your material, it's better to go to define. After that, material property, click it. So you have to use C30 for your concrete property. So make it modify. As I have selected the design code before, so all the data for C30 is taken as it is. So you have to make it okay. So for your rebar data, it's better to modify your rebar data. Select a rebar, and I have to modify the data. So in our case, it's better to use S500 rebar grade. So you have to material type, you have to select a rebar. After this, it's better to use weight per unit volume. For in our case, the weight per unit volume for steel is 78. So you have to edit this data, and the modulus of elasticity for steel is 201, 1, 2, 3. So this is our modulus of elasticity. You have to check. You can check Eurocode. So after that, modify show material property. So you have to use grade 50 or that of S500. So minimum tensile strength for S500 is 500, and that of minimum yield strength is equal to 500 divided by factor of safety, that is 1.115. So you have to delete all the data after the 5 digits. So have to copy this data, and you can use it as expected yield strength, that is FYA. So you have to copy it here. And for that of expected tensile strength, that is FUA, have to use the concrete grade, have to use the reinforcement grade as it is, that is 500. So make it okay. After this, we have defined your concrete property and that of reinforcement property. You can delete this data, or you can put it as it is, make it okay. After defining our material, it's better to define your section property, that is for your slab and your column, stiff column. So I have to go to define section property, slab section. So you can edit this property by modifying it. Modify or show property. So have to use math 600 for this design data. It's better to use 16 centimeter or 600 millimeter first data, and you have to edit it further using your design or analysis output. After that, slab material, it's better to use C30 concrete grade, and modeling type, it's not shell thin, it's shell thick, because it's the thickness is above 200 millimeters, so it's better to use a shell thick. After that, you have to use a stiffness modifier, but in our case, for footing, it's not necessary to use a stiffness modifier, but you can use a stiffness modifier to become more safe, but it's not economical here in design of footing. But you can use 0.5, or you can reduce in 50% that your membrane and bending condition. So make it okay. After that, it's better to you can add some notes regarding to your mud footing. So from this property data, the type is not slab, it's a mud. So you have to change it to mud, and our thickness is 600 millimeter for starting your design. So make it okay. After defining your slab, it's better to define your stiffened column. So to define your stiffened column, it's better to use this data also and make it add copy of this property. After that, you have to write as column, stiff column, and it's better to use this material also, shell thick. The only difference is that our type of properties stiff. So make it okay. Here in this, we have to define both your material property and section property. After this, it's better to define your soil property. That is, your geotechnical data must be defined here. To define your soil property, it's better to go to define. So it's better to go to spring property. From this, you have get point spring. Point spring is for deep foundation, for example, for pile design, and that of line spring is for a wall type foundation or wall foundation. But in our case, it's better to use aerial spring. So click on aerial spring. From this, add a new property. So soil 200. This is because we have a bring capacity from your data of 200 kilonewton per meter soil bearing capacity. So your modulus of elasticity is 1 to 1000 kilonewton per meter cube. As I showed the calculation from this formula, so you have to enter this data. So make it 112. So don't miss the point that make it compression only. So you have to define your soil or geotechnical data like this. So it's better to make it okay. After defining your material property, soil data, and that of your section property, it's better to draw your slab. It's better to draw your slab like this for design and analysis. After that, we have to go to draw your column, your stiff column. So to draw your slab, it's better to use this drawing a rectangular floor. So it's better to use this. So after this property, you have to change the property as much 600 that we have defined before. So after this, it's better to click on this and drag up to the last coordinate like this. So after drawing your slab like this, it's better to draw your stiffened column with the section is 400 millimeter by 600 millimeter to X and Y direction respectively. So to draw your column, your stiff column, it's better to go to quick draw area around the point. So by clicking this, you have to change your material, that is stiff column. X direction, it's better to use 400 millimeter, that is given from your design data, and column to the Y direction is 600 millimeters. So have to draw by simply clicking on the point like this. You have to draw your column at each grid point by simply clicking around the grid point, the center of the grid point, like this. Make it skip. So some data are missing like this. Our column is far apart from the center, 300 millimeter. This is because our column is 600 millimeter to the Y direction. So it's better to expand your slab to 300 millimeter. To do this, you have to go to edit, edit shell, expand or shrink your shell. After this, you have to enter 300 and make it okay. So you have to edit further all these column, by deleting them. You can draw it again, because the center point is not good. So to draw this, you have to go to quick draw area point. So the column is a stiff column and all the dimension is good. So how to draw like this? It's good. You have to draw like this. The center point must be kept as it is. So you can draw like this. After completing a modeling of your project or your math, it's better to define your load case and load pattern plus a load combination. To do this, it's better to go to define. So load patterns. From this, you have to edit in a live load with self-weight multiplier of 1 and 0 respectively. Make it okay. After that, it's better to go to load case. Our load case is dead and live. It's linear static. Make it okay. After that, it's better to go to also your define menu. After that, load combination. You have to combine your load to get your design. So make it add a new combo. After this, combo one may be a serviceability for serviceability. So make it linear add. From this, it's better to use live load and edit load scale factor of 1 for serviceability. Make it okay. Okay, modify it. So make it okay. It's for serviceability, and for your ultimate design, ultimate limited state design, it's better to use another combo. Add a copy of this combo. So it is for ultimate limited state. So you have to use your building design code state factor. In our case, you can use 1.25 for Eurocode, or in Ethiopian building code, it's better to use 1.35 and 1.5 for dead and live load respectively. But for Indian case, it's better to use 1.5 for both dead and live load. After that, you have to make it okay. After completing the modeling of your project like this, and defining all the load combination, load case, and load pattern, it's better to go to assign all the load and soil data from geotechnical report. To do this, it's better to go to select your slab. To assign the soil data, it's better to select your slab first. After that, it's better to go to assign. So go to shell. After this, you have to select spring area. So you have to use soil with bearing capacity of 200 kilonewton per meter square. I have defined before, so make it okay. Our soil data is assigned like this. After that, it's better to go to assigning all the loads that have got on the ETABS output, like a design parameter I have shown before. So to do this, first you have to go to draw a joint object at each column. So you have to click here to draw the joint object like this. After that, you can assign all the dead and live loads that is given from the ETABS output from the superstructure design output at the base reaction. So I will show all the necessary requirements in detail. So I have drawn the joint like this. After that, it's better to go to our design parameter. So the corner column have a dead load of a 200 kilonewton and a live load of 150 kilonewton. So to assign this, it's better to go to select all your corner columns like this. After that, go to assign joint load force. After this, make it date. So go to global Z, that is 200 kilonewton. You can add some moments if it's given like this. So in our case, there is no a moment. So you can add moment like this. After that, you have to go to apply. So our dead load for the corner column is applied like this. Have to add a live load also by clicking and assign it in similar way. So go to assign joint load force. So our load is a live load, which is 150 kilonewton in the Z direction, that is FZ. So have to assign as 150 and make it okay. So live load and dead load is assigned to the corner column, and the next data is that side face column with a dead load of 220 and the live load of 170. So you can select all the face side columns like this. Sorry, must be at the center. Zoom and select the center one. I have to select all the side face column and have to go to assign, joint load, force. After that, I have to make it dead. That is 220. Make it okay. So the dead load to the face column is assigned like this. How to assign your live load for the face column. The live load for the face column and the center column is similar, so you have to assign once. So I have to select the center column also because they have similar live loads. So have to select both the center column and the face column to assign the live load because they have a similar value of live load at the base. So sorry, this is not a face column, it is a center column. So you have to assign joint load, force. So make it live 170. Make it okay. So you have to assign also the center column dead load of center column, which is 300 kilonewton. So go back to your center column. Clicking all the center column and assigning 300 kilonewton, which is a dead load. So we have complete assigning the soil data and all the load like this, but the rest one is we have given a parking live load of 5 kilonewton per meter square because this area is for parking purpose. So we have the load of parking as live load. So I will show how to assign this area load on Safe software. It's simple. So you have to select your slab. After that, go to assign. So our load is HL load. So HL have to select a uniform. So change the load pattern, which is live. After that, you have to select 5 kilonewton per meter square live load. Make it okay. Okay, our live load is assigned like this. After that, make it save your data. After this, it's better to go to analysis and design your model. To do this, go to analysis, run analysis and design, or simply you can press F5. The Safe software itself go to analyze your model. Okay. Analysis and design is complete like this. After that, I have to check some data like deflection, punching shear requirements, and soil stress properties. So to do this, it's better to go to display. So show deformed shape. So go to combo. From this, you have to select combination one, that is for serviceability. Make it okay. After that, the maximum deflection value for this is 3.545 millimeter. You have to compare with the permissible value. So the permissible value is 15 millimeter. So it's less than 50 millimeters. So our design is better for or good for deflection. So you have to go to check your soil stress. To do this, you have to go to show force or stress diagram from this soil pressure. From that, you have to select also combination one, that is for serviceability. Make it okay. The maximum value for soil stress is 42.54 kilonewton per meter square. So it's less than 200 kilonewton per meter square from the bearing capacity of soil. It's good. So you have to proceed to the next part, that is punching shear requirements. So to do this, you have to go to display. After that, show punching shear detail. The punching shear value must be less than 1. If it is less than 1, it's more safe, but it is actually 1. It is safe and 100% economical. So it's better to be less than 1. So some column around the corner is greater than 1. So to do this, it's better to add some depths, but it's good to add some areas also to be more safe. To do this, you have to unlock your model. So have to go to define, that is go to section property, slab section. You have to go to maths, make it modify. So you have to change the depth as 700 and make it 750. It's good. Make it okay. And our column, stiff column, is 750. Make it 750. So that is good. Make it okay. It's better to add some sections also. So I have to click your slab, go to edit. After that, edit shell, go to expand or shrink shell. Have to add 300 millimeter thickness. Make it okay. Okay, our slab is expand like this. So go to analysis and design. It takes some time. So after the analysis and design is completed like this, go to display, show punching shear design. Okay, all the value of punching shear is below 1, so our design is good. After completing the designs of cross-section and depth of mat, it's better to go to design our reinforcement, that is diameter of reinforcement and spacing. To do this, you have to use a strip method, analysis method, and you have to divide it, your slab into 1 meter strip both in X and Y direction. To do this, you have to unlock your model first and go to edit, add or edit design strip. You have to select add design strip using a grid. So from this, you have to make click on create a middle design strip. After that, you have to use a grid system that is global and X direction. You must use a fixed, that is 1 meter design strip. After that, you have to go to OK. So the design strip along the X direction is provided like this in a 1 meter strip. After that, you have to go to edit also, add or edit design strip, add design strip using grids. So you have to change the direction to Y. After that, you have to use, make it okay. So the grid lines are provided like this. To show all the grid data, it's better to go to assessment. After that, design strip width, make it okay. So all the design strip is look like this. You have to uncheck this. After that, you have to go to analysis, run analysis and design. It takes some time as usual. So after the analysis, I will show all the reinforcement, how to calculate the reinforcement. So go to display, show slab design. After that, okay, our design base is strip based method. So rebar location shown at the top and bottom. So make it the value visible. After that, make it okay. So the reinforcement along x direction is shown like this. So the maximum top reinforcement area is 169, and that of bottom reinforcement area is like this in 1 meter depth. These were the most important point regarding to model analysis and design of math or Raft foundation. In the next tutorial parts, that is tutorial parts 2, I will show detailing of this design in AutoCAD. I hope this video is helpful for you. Please like this video and subscribe my channel to get new updates daily. See you in the next video. Thank you for watching.